This is a quick video about this Chinese test fixture for an LCR meter. It is used to connect the device under test with zero cable length settings. The main advantage of this device is its price. It is significantly cheaper than compared to the original HP version. So let's take a look inside and see how it's made. Here is how it is made. Again, everything inside is a metal, which is good, and as you can see, the high and low part of the fixture is actually separated by the shield, which is good. I don't know how it is exactly made in the original fixture, but in this clone this is separated, and I saw in the manual image that it should be like this, so the high and low part should be separated by the shield, and this kind of shield goes inside this gap, as you can see, and it goes out all the way to the top of the contacts. So they are fully separated by the shield. They have the regulation for the contact press force, which are located from both of the sides, but you can adjust it while it's when it is in one piece only from one side. The regulators are visible from here and here, but from this side you cannot reach them so easily, so you need to disassemble to adjust it once. Anyway, so are the good things that I noticed. Let's go from the disadvantages. So the first thing that I see is this huge gap in the shield. So there's a quite large gap, and this is not a good thing, because this one should be completely isolated. So and you cannot kind of bend it or make this gap smaller, because there is no way for this chassis to bend even more. So what I'm gonna do, I will use this copper self-adhesive tape to cover those gaps, and you can buy this from the AliExpress really cheap. They are sold with a conductive glue and non-conductive glue. So you need to buy the one with the conductive glue, and then it goes like this, and it's properly sealed in this thing. Another thing, that these wires are really thin. They are made from the PC data cables, from the flat ribbon cable. They were separated, and they're really thin. So some LCR meters can go to really high current, like HP 4284A. It can do the 200 milliamp AC and with the 100 milliamp DC bias. So I'm not sure these ones could withstand that, and also I'm not sure if they are actually good in insulating things, because the insulation is quite thin, and the bias can reach up to 40 volts. So these ones are very, very weak. So another thing that these wires will bring is a leakage, the current leakage between each of them, or between the wire and the shield, because the LCR meters is actually quite sensitive to the current. It can measure microamps. It needs to have low leakage currents to precisely measure capacitor leakages and other stuff. So this wire can also cause high leakage. And the third thing is they actually quite soft, and they can change position inside this chassis from any physical influence, like vibration or just tilting this fixture would cause change in the position, and this will change the capacitance of the fixture. And if you calibrate your fixture for short and open, and then you can change the position, so your calibration will go up, and this will prevent you from measuring really low values of the capacitance. So what you need to do, or what I will replace this wire with the PTFE insulation This way we will, with a much thicker wire, so this way we will eliminate all disadvantages. So I'm gonna replace this cable with this solid PTFE or PET insulation cable, but you can use just this RG178 or similar cable core stripped out of the shielding. Just it is stiff enough and thick and has also the Teflon insulation inside. Also, I want to add that this part is not interchangeable, at least without disassembling and desoldering the wires. So some people on the internet state that these things can be swapped out on easily and fast, like in original fixture from the HP, but that's not true. This is permanently, at least this model from AU Cole is permanently soldered and screwed to the chassis, so there is no way to quickly replace this. Another thing about this fixture is that you cannot cover the gap completely because it never touches the upper plate, so a huge gap which is really hard to cover with something. So there is no way to move this shield higher because there's almost zero play in this thread. So this is how the final work looks like. The wires were replaced, properly insulated, the solder joints, and the copper scotch was glued on. Thank you for watching.